Good morning, friends. Today we will discuss about single plate clutch. What do you mean by single plate clutch and how single plate clutch transmits power and torque? Let us see today's learning objective. Define clutch, classify clutches, derive expression to obtain the torque transmitting capacity of single plate clutch. You know very well, clutch is a mechanical device which is used to connect or disconnect the source of power from the remaining parts of the power transmission system. And you know very well that means it's connects driving and driven shafts, and this connection is totally depends upon the willpower of the operator. You can say it's a mechanical device used to connect or disconnect source of power to the remaining parts of the power transmission system. You know very well, clutch is used to connect and disconnect the driving and driven shaft as and when required by the operator. But there are another mechanical elements such as coupling, brakes, which are also used to connect driving and driven shafts. But there is some difference. Let us see. The coupling is a permanent connection, you know very well, on driving shaft, driving driven plate, they are coupled by using nut and bolts. That means you can say it's a permanent connection, and to disconnect the shafts, coupling dismantling is required. Then another element is brake. Initially the brake drum is rotating. Here also two driving and driven units. Brake drum is a driving unit and is a rotating one, and braking member shoe is at the rest. How they are engaged? The driving member which comes in contact with the stationary member, that is when they engage, both members are at rest and we are saying brake is applied. But there is no relative motion when it's applied. Remember this thing. That means in brake, one is the rotating member, that is brake drum, another one is the rest member. But during the engagement, that rotating member comes in contact with stationary member, and because of that they get engaged. So there is a somehow small difference between this coupling and clutch, coupling and brake. You have to remember this. Then you know very well where clutch is used. So look at this. This in this figure, it's a vehicle, it's a engine, it's a gearbox. In between this engine and gearbox, there is a clutch. So whatever the motion and power you will get from the engine, it is transmitted to the rear wheel through the propeller shaft through the gearbox. But how to give this power to the gearbox? In between clutch is used. When clutch is engaged, that means power is transmitted from or torque is transmitted from engine to the gearbox, and it's when it's in disengaged position, that means you can say it's a neutral position, then no power or motion transmitted from engine to the gearbox. I have drawn this figure just to say where clutch is or its position is in between engine and gearbox, engine and gearbox. Remember this thing. Now when it is engaged, that means clutch is engaged, and again you will find here in machine design engineering, friction plays important role. Somehow we try to reduce the friction to have a more power transmission capacity, but here in clutch that friction is utilized to connect the driving shaft and the driven shaft. Remember that thing. The friction plays important role for transmitting torque as well as the power. Now there are some classification: positive contact type clutches, friction clutches, electromagnetic clutches, then fluid clutches and coupling. The positive contact clutch. You look at the figure, you will find here this clutch, positive contact clutch, are having the jaws. This is the jaws, or you can say tooth construction. Because of that, what is going to happen? The power is transmitted by means of interlocking of jaws and the teeth. Positive engagement is there, and they can transmit large torque with no slip. But generally it's used under 10 rpm. That means very low speed application. Remember this thing. Another type of clutches are the fluid clutches and the couplings. In fluid clutches, the fluid is used, or a fluid coupling provides extremely smooth starts and absorb the shocks compared with the other clutch. And here, power transmission by means of hydraulic pressure. Remember this thing. But our, the main aim of this, the topic or our focus is on friction clutches. You know very well, you might have heard the word single plate clutch, multi plate clutch, cone clutch, centrifugal clutches. All these are the friction clutches and power transmission by means of friction between the contacting surfaces. The main advantage of this friction, this is the third classification. The main advantage of these friction clutches are engagement is smooth. Once clutch is engaged, there is no slip between the contacting surfaces. Contacting surfaces means frictionless. There are power loss and consequent heat generation do not create the problem. That means no power loss compared with the other clutches in case of friction plates. It's engaged. In certain cases, clutch acts as a safety device and it slips when its torque exceeds the safe value. That time, clutch is going to slip, and because of that, it acts as a safety device. Remember these things. Then there is another classification in electromagnetic clutch. In electromagnetic clutch, you will find the further classification of electromagnetic clutches are particle magnetic particle clutches, magnetic hysteresis clutches, and eddy current clutches. But look at the figure. Here the gearbox, here the engine, and in between there is a clutch. Why word is electromagnetic is used here? In this case, the rotor and there is a winding. It's like electric motor and the armature on the another driven member. Because of this winding and armature, what is when current is passed through this winding, what is going to happen? Magnetic field gets generated here, and because of that the driving shaft gets connected with the driven shaft within a microseconds, and because of that the clutch gets engaged. And that's why this electromagnetic clutch is having advantage of rapid response time, ease of control, and smooth starts and stops. Remember these things. That means it is totally based on the principle of magnetic field generation because of this winding and the current. Remember these things. But our focus of this topic is on friction clutches. The friction clutches further classified into two types depends on the friction surfaces. One is single plate clutch and multi plate clutch. That means when single friction plate clutch, the or friction plate is used, you can say single plate, or multi plates are used, you can say the multi plate clutches. Again, depends on the shape of the friction material. Disc clutches, brother clutches, friction clutches are classified as disc clutches, cone clutches, expanding shoes. Again, how to select the clutch for our application? There are some, the factors that you have to consider while designing these friction clutches. The first factor is select proper type of clutch, whether single plate, whether multi plate, whether centrifugal. That means what we have to do, we have to take into account which type of clutch for particular application. This is one factor. Second one is the which type of material, that is friction material for the contacting surfaces. Asbestos and other, the friction lining materials are used. The which type of friction material for the contacting surface. This is the another factor. Third one is because based on that we will select the coefficient of friction. Then designing the clutch for sufficient torque capacity. How much is the torque transmission capacity? For that torque transmission capacity, we have to design this. And third one, engagement and disengagement mechanism, and it should be with and without shocks and jerks. Without shocks and jerks. These are the general factors to be considered while designing the friction clutches. Again, another factors that you have to take into account. One is the provision for holding contacting surfaces together by the clutch without any external. You know very well in two-wheeler and four-wheeler you will find the clutch lever or the clutch pedals are used. But there is a holding, the provision for holding. That means springs are used. Springs are used. Because of that, they are in engaged position. Remember this thing. That means this is also the another factor. How to hold the contacting surfaces together without external assistance. Then low weight of the rotating parts is the another factor. Why it is important? Because it reduces the inertia forces in high speed application. That's why the low weight of rotating parts. Third factor is provision for compensating wear of rubbing surfaces. You know very well the friction materials or friction plates comes in contact to get engaged these driving and driven shafts. But after some period of time, the friction lining material gets worn out. That's why what is the provision for compensating that wear of the rubbing surfaces is the another factor. And last factor, provision for carrying away the heat generated at the rubbing surfaces. And when they are in coming in contact during the engagement, what is going to happen? Because of this friction lining material having a high coefficient of friction, heats get generated, and how to dissipate that heat from these rubbing surfaces is also an important one. So all these are the general factors that we have to take into account while designing the clutches. Now look at this single plate. Our today's focus is on to discuss single plate clutch and how to derive the expression to transmit the torque or torque transmission capacity of single plate clutch. Let us see here is a driving shaft, is a driven shaft, and we have to connect this driving and driven shaft. Totally depends on willpower of the operator. For that purpose here, this single plate consists of driving shaft, one which here this is the flywheel and friction lining material, or you can say the friction plate. Another plate on the driving shaft, the driven shaft is the pressure plate, and I have shown the sleeves here. This arrangement is made to shape the by using the lever we can apply the force or the pressure on the pressure plate to engage and disengagement, and accordingly we can move this pressure plate towards left and right. And for that purpose, to have a proper engagement, here springs are used for actuation. When we are going to move towards the right, what would happen? These springs are gets compressed, and when we remove this the force, it's regain its original position, and this the friction plates come in contact, or in general driving shaft comes in contact with the driven shaft, or power or motion transmitted from driving to the driven shafts. Okay, remember these things, and that's why these driving shafts, oh sorry, driven shafts as having the splines, and because of that the axial moment of the pressure plate is possible on the driven shaft. Remember these things, and this is the friction lining material I have shown here. Here is a gap, and because of this friction lining material, when we apply the force or pressure, this the driving and the driven plates comes in contact because of this friction lining material, and it transmits the torque from driving shaft to the driven shaft. Remember this thing. It's a single plate. Why it is known as a single plate? Because this, the single friction plate is used having the friction lining material. That's why it's a single plate clutch. Then single plate clutch is used in many automobile applications. You will find buses, cars, trucks mainly uses this single plate clutch. Why this buses, cars, trucks uses single plate clutch? Why not multi plate clutch? Because here you will find due to the large radial space of the single plate clutch, it mostly used in large vehicles. Because of single plate is used. That's why to have a large torque transmission capacity, the outer diameter, or you can the dimension of the single plate clutch is also more. This is one, the large radial shape. But another question, because of this large radial shape, amount of this efficiency is also more, and therefore no need to use lubricant or oil to cool the plates. Then third one, due to large radial dimension or a shape, high coefficient of friction that is achieved through the single plate, and amount of that coefficient of friction is more than zero point 0.3, and because of that amount of torque generation is also high. Because of most, and this torque generation is high, and because of this mostly it is used in big vehicles, buses, cars, trucks. Remember these things. Why single plate clutch is in buses, cars and trucks? These are the reasons. Remember these things. Then how to find out the torque transmission capacity of single plate clutch? Remember, look at this. Now this is the friction plate is having small d is the inner diameter of the friction disc, outer diameter capital D is the outer diameter of the friction disc, and P here the intensity of pressure at the radius are now here. What we have done to make the analysis or to find out the torque transmission capacity of the single plate, the simple annular ring having the dr thickness is considered at a distance of r from the center. Look, remember these things, and force speed which is applied to engage and disengage, and it's remain during engagement, the spring action is also exert the same intensity of force on that. That's why P is the total operating force, and small p is the intensity of pressure at the radius r, which is shown in this figure also, and emt is the torque transmitted by the clutch. The capital D is the outer diameter of the friction disc, small d is the inner diameter of the friction disc, small p is the intensity of pressure, unit is Newton per mm square, Capital P is the total operating force. Now let us consider small elemental ring, that is dr, at a distance of r for the analysis. Now the intensity of pressure again on this region from the inner diameter small d to up to this portion, because pressure which comes on this friction plate on this annular total ring, you can say capital D minus small d is the annular ring where we can apply the pressure. The here what we have to do, the intensity of pressure P at the radius r may be constant or variable. But what you have to do to make the analysis simple, for the small elemental ring we have to consider elemental ring of radius at a distance of r and radial thickness of dr. The elemental, how much is the elemental area? Is annular ring, that's why 2 pi r into dr. So what is the elemental axial force? This is the area into, you can multiply it by the intensity of pressure. P intensity of pressure into 2 pi r into dr. This is equation A. Similarly, we from this force we can find out elemental frictional force. Frictional force just multiplied by mu coefficient of friction, you will get the modified equation mu p 2 pi r dr. And elemental frictional torque, this is the frictional force into small r. So mu p 2 pi r into dr into r, that is F into r. Frictional force into r, that is frictional torque. You can say it's equation B. The integrating this equation A, the P is equal to 2 pi PR into dr. Again, why the integration limit is from small d by 2 the capital D by 2? Refer this figure, because it is going to vary from this. This is the inner diameter of the friction disc. The from this to the outer diameter, so that's why d by 2 up to the capital D by 2. This portion that we have to consider to find out this torque transmission capacity. That's why this capital P is equal to 2 pi in integration limit from small d by 2 to capital D by 2 PR into dr, equation C. This is equation C. Then what we have to do, this equation B, elemental frictional torque, that we have to again integrate. The integrating this equation, it's a frictional torque. The MT is equal to 2 pi mu PR square into dr, and again limit, the same limit that we have to use d by 2 to capital D by 2. So we have two equation here, the equation C and equation D. But one is for the elemental axial force, another one is for the elemental frictional torque. And by using this two equation, we can easily find out the torque transmission capacity. But here, there are two theories are involved in design of clutch. One is the uniform pressure theory, another one is the uniform wear theory. Now let us discuss about the uniform pressure theory. We have already discussed the theories also, but let us see. In uniform pressure theory, what do you mean by uniform pressure theory? The pressure remain constant over the entire surface of the friction disc. Remember this thing. That means on this surface from this small d by 2 top to capital D by 2, on this area or annular ring total surface area, pressure remain constant according to uniform pressure theory. But when it is possible, when clutch is new, springs are new, then and then it's possible. After some period of time, it does not remain a constant. Remember this thing. So for a new clutches, we can use uniform pressure theory. But when it's uniform pressure theory, but when clutch gets worn out, so we have to, after some period of time, it gets worn out. And that time we have to use a uniform wear theory. So while designing the clutches, always prefer uniform wear theory instead of uniform pressure theory. But uniform pressure theory is applicable to only new clutches. Remember this thing. Okay, now we have to find out the torque transmission capacity of the single plate clutch based on uniform pressure theory. Let us see uniform pressure theory. The uniform pressure theory, pressure remain constant over the entire surface area of the friction disc. Therefore, P is assumed to be constant, P is equal to C. So now consider equation C, earlier equation, this equation C. P is equal to, I have written this, P is equal to 2 pi integration limit from d by 2 to the capital D by 2 into PR. What we have to do? We have to replace this, the P is equal to constant, so you can take it out. So what is going to happen? 2 pi P integration R E dr. After taking the integration, what is remaining? The R dr integration, you will get R square by 2. I have taken this, substitute the value of limit here, d by 2 to capital D by 2. You will get this P is equal to pi by 4 small p d square minus d. Remember this equation A. Then we have to take into consideration, that is equation number, this equation number D. The equation number D is for elemental frictional torque. Now from this equation, elemental frictional torque, again P is equal to constant. So you can take this P outside. the 2 pi mu p and integration dy to capital dy to r square into dr. So what is the integration of r square dr? R cube by 3 dy 2. Okay, and you will get this equation here after substituting these limits. You will get mt is equal to pi mu p by 12 d cube minus d cube. So what you have to do? Divide this equation here by p. The mt by p. The mt by p, if you are going to divide this equation by this, you will get in final expression mt is equal to 1/3 of mu p d cube minus small d cube upon capital D square minus small d. This is the equation. So you can say this equation is used or it gives us torque transmission of the single plate clutch according to when we use uniform pressure theory, or in other way, according to uniform pressure theory, torque transmitted by single plate clutch is given by this equation. Remember this thing. This is according to uniform pressure theory. Now let us see the uniform wear theory. In uniform wear theory, wear is uniformly distributed over the entire surface. Barabar. But what is happening? It is used for worn out clutches. Newly clutches, we can use a pressure theory, but after some period of time, clutch gets worn out because of sudden engagement and disengagement of the clutch. That's why it is used for worn out clutches. That's why while designing the clutch, always you have to use uniform wear theory. The axial wear of friction clutch is again this is proportional to the frictional work. In this case, the axial wear of the friction disc is equal or proportional to the frictional work. So how much is the frictional work during engagement is going to happen or occur is equal to the axial wear of the friction disc. Therefore, work done by the friction force at a radius r is proportional to this frictional force and rubbing velocity between the contacting surfaces. But here you will find, therefore, based on these two, the wear is directly proportional to mu p frictional force and rubbing velocity 2 pi r n. But here you will find this speed n and coefficient of friction mu remain constant. And what is remaining? P and R. 2 is also constant. Therefore, wear is directly proportional to PR. Now here in earlier in uniform pressure theory, we have assumed P is equal to constant. Here in wear is directly proportional to PR. But when wear is uniform, PR is constant. And in the what is going to happen? Pressure is inversely proportional to radius. Therefore, pressure is maximum. Look at the second figure. It's a constant uniform pressure. But here you will find intensity of pressure at the inner radius, that is small d. It's a maximum and it is going to decrease at the outer diameter. Look at this. The intensity of pressure at the inside diameter is high and it is going to decrease. You will observe from this figure. So you can say pressure is maximum at the inner radius and minimum at the outer periphery. And this pressure, instead of showing a small p, so we are going to use the suffix APA. This pressure is denoted by PA. So we are going to replace this PR is equal to PAD by 2. The PR is equal to constant, P is replaced by PA, and R is nothing but a small d by 2. So what we have to do? Again here we have to use the expression, this P is equal to our this equation PRDR. The equation C, I am going to write P is equal to 2 pi integration d by 2 to capital D by 2 into PRDR. So what is PR? PA into d by 2. I have substituted PA into d by 2. Again here what we have to do? Again PA and dy 2 that you have to take out. So what you will get, the only dr remain inside. You can take the integration and solve it by using these limits. You will get p is equal to pi by 2 pa into d minus d. Then another equation d that you have to use. Where is the equation d in on earlier slide? mt is equal to, this is elemental frictional force, frictional torque. This equation we have to use to find out the torque transmission capacity by using uniform wear theory. This is the expression. Again, we have to replace PR by this PA into D by 2. I have substituted this value. You can solve it. You will get again the RPR square. The PA R square means here D by 2. You have to use the square. Here R in terms of this R written. Here this R is written. This R square. So remember these things and take the integration R square by 2. Then what is going to happen? Here you can substitute these limits of integration. You will get mt is equal to pi mu p a d by 8 d square minus d. And if you are going to, here in general, what we have to do again? So we have to use these two equations and divide mt by this p. So you will get mt is equal to μp by 4 d plus d. So by dividing mt by this equation by this, you will get this expression. So you can say 1 by 4 mu p d plus d is the torque transmission capacity for a single pair contacting surfaces when we use this uniform wear theory. That means we have two equations. One is this equation according to uniform pressure theory. Another equation, this equation according to uniform wear theory, to find out the torque transmitting capacity of the single plate clutch. This is about the derivation. Sometimes in examination, question may be derive the expression torque transmission capacity of single plates according to uniform pressure theory, according to uniform wear theory. So you can do this analysis. Okay, this is about the torque transmission capacity of single plate clutch. I have referred Vivender's book. Thank you very much. Thank you.